What is chain rule? If you have a composition of two functions, let's say f not g, and if you are interested in finding the derivative of that composite function f not g, then the derivative of that by using the chain rule will be: find the derivative of f, evaluate that derivative at g. So we have the composition of f prime with g times g prime. So by the chain rule, the derivative of f naught of g will be f prime, evaluate that at g times g prime. Let's see one example. So here our goal is to find the derivative of square root of 3x plus 1 with respect to x. So if you want to use the chain rule, we need to make sure that this function is the composite of two functions. So you can see here, if I assume f is square root of x and g is 3x plus 1, you can clearly see that when we compose these two, so if we compose f with g, you can see that I need to evaluate function f on g, so that will be replacing x by 3x plus 1, so we'll be immediately get this square root of 3x plus 1. So this make a sense that the square root of 3x plus 1 is the composite of square root of x and 3x plus 1. So when we also have what is f and what is g for this formula. So let's try to apply the chain rule to find the derivative of the composite function. So on the chain rule, you can see there is f prime. We need to evaluate that at g, and also we need to know what is g prime. So we already know what is f and g, so let's first find what is f prime and g prime. So what is the derivative of square root of x? Alright, let's try to see if the function is square root of x, then how to find the derivative of that. So since f of x is given as square root of x, so we can actually change the square root of x into the exponent form as x to the power 1/2. So when we write into that form, then we can clearly see that we can actually use the power rule. So we can just bring the power down, right? So 1/2 is down, write down the x as it is, subtract the power by 1. So we can just apply the power rule after we change the radical into the exponent, and this is the derivative. If you want to rewrite into the alternative form, we can simplify the power. So this will be 1/2 times x to the power 1/2 minus 1 will be negative 1/2, right? And that's also another like alternative form, the derivative of the square root of x. Or if you want to change this negative exponent into the positive exponent form, then this can be written as 1/2 over 1/2 times 1 over x to the power 1/2. And now if you want to also change the exponent into the radical, this will be 1/2, right? So or 1 over 2 times square root of x. So this is the derivative of square root of x. Okay, so the derivative of square root of x is 1 over 2 times square root of x. What is the derivative of g? 3, right? And now we have f, g, f prime, g prime. So we have already figured out what is f prime over here. You can see on the chain rule, we need to first evaluate the f prime at g. So why don't we let's compose this f prime with g. So how do we evaluate f prime of g? We need to replace x here completely by this function 3x plus 1. So when we do that, we get 1 over 2. When you replace x by 3x plus 1, we get 1 over 2 times square root of 3x plus 1. So this is your f prime evaluated at z. So f prime function composed with z. That's how we have over here. Now times, we need to just multiply by the derivative of g, and which will be just times 3. We are done. This is the derivative of the square root of 3x plus 1 by using the chain rule. If we want to rewrite this, we can multiply 3 by 1 to the top. So we have 3 divided by 2 times square root of 3x plus 1 is the derivative of square root of 3x plus 1.